Okay, so coming back to this problem of a circular hole under uniaxial loading. So we last time set up the problem, defined material properties, set up boundary conditions, and then solved. And we were shown a result of von Mises stress, surface deformation. Now we want to go through and verify if it's correct or not. And one way of doing that is comparing this to theory. So as I mentioned, the stress in the y direction should be 3 times the applied stress at the hole at this point. So what we're going to do is we're going to plot sigma y along this line and see what the stress concentration looks like. So to do that, let's first go back to the geometry and find out exactly how big this hole is and where this point is. So you notice we have a radius of 0.1. So we're going to come back here. Let's see how we can set this up. Alright, so one thing let's first do is change this from a von Mises stress to stress in the y direction. So down here I change this to SY. That gives me my Cauchy stress in the y direction. So I think we have to click this button to plot it. See, now you see a change. And one interesting thing is, if I zoom out a little bit, so remember we put 1 MPa here. And you notice this red region is close to 3 MPa. So that's a good sign. It's 3 times the applied load. But let's take this a little further and let's see if we can plot it on a line. So let's see if we can add a line. Let's see what this does. No, this is not what we want. So if you right click on this, delete that. So data sets, so here's our solution. So if I right click on this, I believe what I want to do is cut a line in 2D. So if you left click, cut line 2D, and here are your 2 points. So we want to pick up this point and this point. So that is at point 1, y is 0, y is 0 at the other point, and this is at 1. Okay, so that's our point. And let's come back here. So if I right click, I believe I need to go to this surface plot. That is not it either. If I right click here, if I add, where do I want to add this? Alright, so coming back, under results, if I do 1D plot group, okay, so this adds this here, and now I believe we have to right click again to do a line graph. Oh, maybe we can do this directly without cutting the 2D line. So I've created a line graph, and now here I can type solid SY to plot sigma y across here. It's going to plot it over an arc length. You could use an expression, but that's fine. So if I click this button, this should plot, and we get nothing. Alright, let's see. thought that it had to be connected, and instead of from parent, I believe we need to use this line. So this defines the geometry. So you need to connect it with a point or line, in this case, on the material. So now let's try plotting. There we go. Alright, so you notice as you move away from the circular hole, the stress is almost the same as the applied load. There's no concentration. And then as we move up, this is almost 3. It's not exact, but it's close to 3. So we have reasonable confidence that it's correct. So this gives you some idea. Other things you can do is export this and plot it against the known solution. So then you can do an exact correlation. In the next set of next video, I'll show if you refine your mesh, this will become more smooth, and